There's so much parking knowledge to fit inside our heads. It's sort of a complex decision process. What system are you using that's like most cost effective?
This solution, this would be like the most economical. I have traditional parking stalls behind with a sliding platform in front. You have double stackers, triple and quad stackers. We call it vertical tandem. The machine can have a whole array of parking spaces and not waste any space because they share a common leg. You have puzzle systems, and this density is off the charts. All of our parking, 64 spaces, consolidated into this 5-level system. For a high turnover project where it's a mix of uses and a lot of peak time, you're going to go more with a rack and rail. On the automated AGV is going to be more expensive than a rack and rail. Typically, the AGV can access those spaces that it couldn't do normally. One of the nice things about the AGV system too is it's interchangeable. Swap out my parking spot for a storage container. For the future, what we're seeing in municipalities is converting high volume spaces into other uses. It's a trend that we see municipalities planning for. Creating these higher volumes of space that then in the future get converted to other uses. That system can be adapted and modified to accept whatever that future is. Well, my name is Michael O'Brien. I'm the Group Vice President of Engineering for Park Plus. I've been with the company for a little over 10 years. I'm originally an architect working on urban infill mixed-use projects was my specialty. I always joke that every project I did was dictated by parking in Los Angeles. Form follows parking. Every project was dictated by the parking grid and the number of cars and how we were going to get all the cars in there, and then we could figure out what we were going to build on top of that. That kind of led me to get into this industry and start looking at better, more creative ways of solving the parking solution. Park Plus has been around since 1969, started in the New York metropolitan area. We have over 250,000 stackers just in New York City alone. Probably, easily 1,000 plus projects throughout the United States. We're finishing our 100th project right now here in Southern California. Even though it has been around so long, it's not since the last 5 years has it really become accepted. Obviously, the larger municipalities have accepted it, but the smaller municipalities some of them are starting to see it for the first time. It's funny because you have to go through this whole experience, the whole educational process of explaining to them what it is that we're doing and how these systems work.
Of the 100 projects in Southern California to date, how many of those are housing?
Probably about 50-50, so half commercial, half housing. Most of them are in this area. There are more cars per square mile in the city of Los Angeles than any other city in the world. So we have a definite vehicle issue here. We also have the most stringent building codes anywhere in the world. The city of LA in particular is the hardest municipality in the entire world to build these type of systems. We are doing a lot of TOC type projects, so they're not getting rid of the parking, they're just reducing.
Let's just start with an overview of 4 primary categories of parking systems out there, starting with the least expensive, least complex to the most expensive, most complex. So first, sliders, the stackers, and then the puzzle systems, and then the automated systems, most expensive, most complex then.
I get into a variety of different system solutions. You have sliding platform type systems. You have double stackers, triple and quad stackers. You have puzzle systems and suspended platform systems where the cars are hung over the driveway. You have fully automated solutions. So we have 2 different versions, rack and rail or AGV.
And in general, how much do each of these systems cost on a per parking space or stall basis?
You're running right now in LA City. Keep in mind, this is the most expensive place to build any of this stuff. But just the slider itself, you're around $7,000 to $7,500 for a sliding platform. Double stacker, you're probably $14,000 to $15,000 a stacker. For a lift slide puzzle system, 2-level puzzle, you're somewhere between probably around 40,000 to 45,000 space. If you get above 2 levels, 1 up or 2 over, you're probably in the 50 to 52,000 a space. On the automated AGV is going to be more expensive than a rack and rail typically, because you have more devices within that. So they're probably leaning on average for small projects in the 50,000 to 55,000 a space. On rack and rail, it might be less. It might be in the 40,000. On bigger rack and rail projects is where you really see that you could be hitting 29 to 30,000 a space on a bigger rack and rail.
The only systems that you sell that need a valet are
triple and quad stackers and a double stacker. If you weren't assigning the parking spaces to each unit, then you would.
Great. Well, let's take a deeper dive into each one of these solutions, starting with the sliders.
This solution, this would be like the most economical. I have traditional parking stalls behind with a sliding platform in front. So all I'm doing is creating that void to get to the tandem spot. So if you did your column grid right, you could in essence take a whole row of parking like this. This could then be individual users. So for these TOC type projects, I can densify my parking. All I have here now is this sliding platform that can slide out of the way to allow me to drive through the back spots.
So the slider adds some density in a very simplistic way, but the stacker adds even more density just by giving you the ability to go vertical.
The stacker is definitely your most economical solution at the end of the day. It's the bread and butter majority of our clients are looking at. So it's a platform that runs up and down two legs, and it's a mechanical system that locks into place in the upper position. We have an 8'6" standard module, and we have a 9-foot standard module, as well as we have two other compact modules. So it's designed to share a leg, so a machine can have a whole array of parking spaces and not waste any space because they share a common leg. This is the old papermate pen factory in Santa Monica, 240 double stackers, so we get 2 rows of cars. So we have 240 in a quarter-mile long garage. This is a small lot subdivision. 5 new houses on the small lot subdivision, and they used a stacker for every unit in this case in order to get the 2 cars per unit. We're even seeing, ADUs, and then built an ADU on top but in order to have 2 cars per unit, they did a stacker. This is Venice Beach. This is right at the boardwalk, servicing residents, hotels, restaurants. Some people that are leasing spaces on a monthly basis. You have people that are just coming to the beach. You got a little bit of everything.
You don't have to have an attendant for a double stacker?
If it's a resident use, both of those spaces are then assigned to that unit. It's with an old 1950s apartment building, courtyard housing type project. It had originally 1-story carports, and every unit had 1 car. Most of the units were 3 bedrooms. What we did was raise the carports and put a stacker, and so each unit gets a stacker, and they just manage their own. So we call it vertical tandem. There are no attendants on this particular project, so everybody operates their own stacker. A couple will shuffle their own cars. What I've found is they just take the most convenient car. So we've done a lot of triples, and we also do a 4-high stackers as well. Primarily be a commercial application, or it would be a Valet scenario.
All right, so now we're moving from sliders to stackers to puzzles, which take the stacker and give it further capability, both going higher and to the left and the right.
Yeah, so puzzles kind of come in a whole range of options. Those systems are usually running anywhere between 35 to 50,000 a space, depending on the configuration, quantities, etc. So puzzles is not really automated. Really a stacker that you're parking in. The way it works is you basically have a vertical void to allow you to have access into the upper levels. They all slide right or left in one space, and then everything from 2 through 4 go slide and come up and down. This is a 63 unit affordable housing, and this is a full moment frame steel system. This one's a fully galvanized system because it's outdoors. Everything is above grade. You can see we even have an integrated sprinkler system running within the racking system as well. So it's a 5-level puzzle system, and these are also in tandem. Front spot opens so you can drive through to the back spot as well. And this density is off the charts. It's 64 cars. All of our parking, 64 spaces, consolidated into this 5-level system. It would have taken 2 full subterranean levels across the entire site once you put a ramp in. All in, you're looking at probably 50,000 space, including the structure and the system, right? Whereas if you're doing a subterranean garage, probably been in the $90,000 to $100,000 space range.
What other configurations does the puzzle system come in?
This is the same as the 5-level system. It's just 2 levels instead of the 5. But you're probably in the 35 to 45,000 space range for these systems as well. As a double stack slider.
A double stack slider. It sounds like a burger.
So we have these all over the place. So in this case, you'd have the gate in front of it, raises up the upper one, and then below you have a slider. The platform on the bottom will then slide over to the side.
Valet free.
Yep. Enter at the mid-level, or the car comes from below or comes from down. So in section, you only have the smaller footprint. This is my main drive aisle. I'm entering at that level. That's your most efficient way of doing the parking. This is a 49 unit building, but it's designed as co-living units. So being rented out is 150 plus units. You have a code requirement here for 49 units. At the same time, the developer knows that he needs to provide more than 49 parking spaces. Total parking somewhere around 70. This is that surface space. This is that sliding platform, but I've created a pit underneath. So I have another car under there. So the same thing happens. I slide to the side on this level, and then this car pops up into that void that I already had. So I get another row of cars underneath. Because it's LA, I had to do the higher pit, but if it was New York City, I would have dropped it even lower.
So you can actually enter at halfway.
That's
halfway
right.
down.
You get a full row across the top, you get a full row on the bottom, and then you have the one voided grade. So that gets the most efficient number of parking spaces when you do that type of system. What I have along here is a gate along here, so this whole thing is kind of cordoned off. So as a user, if I have car 44, I just punch in a code for my car, and it automatically will slide all the cars out of my way. For example, if I wanted this car, it could slide the entire row up, and then now I have a void, and then I can drive right out.
You would walk in to the car in that corner there, reverse the tandem out.
The gate would close afterwards.
I'm assuming when the gate is open and you're accessing your car, those cars aren't going to come sliding back at you.
No, when you pull it out, then what happens is it'll close the gate and then it will move. So there's always a gate in front of that, so no car moves while someone's in the system. Primarily would be a residential application. So you would be trained on how to use the system. You would have your own access code, everything. And it's assigned parking. So I'm always parking in space number 47, or I'm always parking in space number 55.
Very cool. What other ways can you configure the puzzle systems inside a garage?
This is the West Hollywood rec building. So we double stacked the parking off to the sides, but we also hung the cars over the drive aisle as well. We call it a spin platform. It's in the same family as the puzzle. It just doesn't have the sliding portion to it. This garage is a density of about 65 square feet per car. It's the densest one I've seen by far, because what happens is your entire ceiling grid is now full of cars. You don't waste the space. A platform drops down into the drive aisle, you park your car on it and pop it back up. So that idea of creating these volumes where I can either keep the cost down, park cars traditionally, or I can add whatever exponential amount I want in there, whether it's over the drive aisle, double stack the space. As the tenant mix and changes, I can change it by changing out the equipment within the garage.
And to the fourth category, we're moving to fully automated parking systems, which are in two categories, either rack and rail or this automated guided vehicle system.
Fully automated solutions, you're coming into a loading bay, and that's really like pulling into a two-car garage, and you're dropping off your car. As far as you're concerned, that car stays in that garage. So as far as you know, I left my car in that garage, and when I get back, it's magically turned around and coming out to me the other way, right? The beauty of these systems is that, the interchangeability, the ease of installation. Fire departments love them because there's no mechanisms on the floor. The little robot itself is picking a platform, and that platform is then being picked up and transferred throughout the garage.
So that automated system, the components are a lift.
Lifts can either be in the loading bay or adjacent to the loading bay. And then you have either an AGV system, the AGV, or you would have a shuttle and dolly for the rack and rail. So the shuttle would move back and forth, and then a similar device to an AGV would come off of that shuttle to transfer the car on and off into the parking spaces. AGV, so it stands for Automated Guided Vehicle. So it's just a robot that runs under, picks up the platform.
Like the Amazon distribution center.
Yep, exactly. It's actually a barcode that's reading, so it knows where it's going, and so it's just, as it traverses through this area, it's reading the position on the floor. So it knows it's in, every one of these has an X, Y, Z coordinate grid to it. And it's just confirming position as it travels through the garage.
It's pretty cheap, I guess, just to put the little stickers on the ground.
Yep. Yeah, they're literally little stickers that get stuck down on the floor. So we do everything from small systems like 6 or 7 spaces to larger systems. We're building the largest one in the United States, which is over 400 parking spaces on 13 different levels for a large residential project in South Florida. The cost on that range depends on a lot of factors, and the main factor is the amount of throughput that garage sees. That loading bay, that little private garage you're parking in, well, that's your bottleneck. So depending on how many users are coming in and out in an hour, you need to design enough loading bays for cars to come in and out. On average, you got 15 to 20 cars in an hour that can come out of one of those cubes. The more devices you have, obviously the price goes up and down. So AGV could be anywhere from 20,000 a space to 50,000 space, possibly 70,000 space if it's a super unique situation. The more cars you have, usually typically the less the cost is.
So what's the key advantage of using this system versus conventional parking?
So you really get a lot of efficiency, probably in the 200 square foot per car versus a normal podium type garage somewhere in the 450 square foot per car.
Yeah, so it really comes down to parking density of how many cars you can park into a limited amount of space. And this automated system just allows you to quickly pack in cars 3 deep and in tightly constricted spaces where you just couldn't do it on a conventional parking grid.
A lot of our projects are triple tandem. This is a good example of one we're doing in the Arts District that is triple tandem. This one's in plan check in LA right now. This one is a rack and rail. We have a huge mixed use project, right? And so you're driving down into the first level and you have a series of different loading bays set up for different uses. Green being residential, the blue being commercial and hotel. And this particular system is designed to turn a very high volume. There's a ramp here, and then now for residents, the residents circulate around and go here. Commercial uses can go here. And so there's a combination of valet for a hotel. In this case, the elevators are removed. So from the loading bay, it transfers into the system, and there's a shuttle that goes back and forth. And then these darker blue are the lift.
Those lifts are just going down to the floor below.
Yep, which then has two layers of cars stacked within that volume space. And then you have the residential or the green ones, so they can enter in and then drop down. That's dropped down here, and now it's being transferred into the racking system.
3 cars wide.
Yeah, that's pretty standard. You know, you're in that 25 to 30 foot grid range for mixed use buildings because it's on fixed rails, so you can literally run as fast as you possibly can down that area to get quicker access to the car. So for a high turnover project like this, where it's a mix of uses and a lot of peak time, you're going to go more with a rack and rail. We have the issue in LA of the 50 by 150 foot lots, right? And you know, the core and everything ends up being in the way as well. The AGV can work around all of those components, give you a layout you couldn't do, you know, traditionally. Like you might get more cars a lot of times on an AGV that you wouldn't get in a rack and rail. This was my aisle, and this portion of the garage was the same for a rack and rail. I couldn't get these cars behind the elevator core on a rack and rail because everything runs in an X, Y, or Z axis. Whereas the AGV can come down, drive behind, and drop the car off behind. So the AGV can access those spaces that it couldn't do normally. We have a lot of 50-foot lots from the high rise and having 4 levels of this kind of rack and rail type system off of a loading bay at the entry level. And this is looking at multiple levels. And so we're parking, you couldn't even park this garage traditionally. In this case, we have a loading bay at grade here. So what happens is you enter in off of the street level and then the cars go up.
That's the elevator in the bottom.
Yeah,
right.
That's a shuttle.
Like that whole thing has to stay.
That's correct. And that works like a drive aisle for this, which is a rack and rail. The AGV solution, you can put cars in the drive aisle if you wanted to, right? So you can see how there's a couple of cars stacked in the drive aisle. It'll unstack a car from here and place it in the drive aisle and grab the back car and take it to the loading bay. This same plan would work for an AGV. It's just the AGV would take it off the lift, use that same aisleway, and then drop it into those positions.
Yeah, so you might be paying a premium for the AGV system over the rack and rail, but the AGV system is also giving you slightly higher density. And then as far as the other equipment involved, is the elevator that's moving the cars between levels basically the same between the AGV and the rack and rail system?
And we've now standardized a similar elevator solution for both, what we call VRC, which stands for vertical reciprocating conveyor, and that's just a fancy term for a non-passenger elevator. With an AGV system, we now do what's called a tray accumulator. When they're not being used, it keeps those stacks of trays in the garage. The lift itself holds a stack of trays. Because there's a stack of trays, that lift just goes right back up and it's ready to take the next car. That adds obviously a lot of devices and a lot of cost because you're adding all these devices to that mechanism.
In comparing the automated systems to traditional parking, what are some of the design considerations for building a parking garage, and what are some of the maintenance considerations in maintaining the parking garage?
Some of our garage floors, especially multi-level systems, we do different floor heights on different floors. So like we have some areas by the lift that are set for 8 feet 2. The rest of that floor is set up for 7 feet. And then other areas of the garage are set up for about 6 feet to 5.5 feet. We try not to do that, but in New York City, it's very common for us to do John Malkovich floors.
John Malkovich floors, I love that.
Fire in particular is probably the worst with dealing with these type of issues. And as long as they're getting 6 feet, 6.5 feet overall clear, they're pretty happy. They are pushing for higher volumes these days. So a standard car now is required to be 7 feet tall, and a compact car is required to be 6 feet.
From a maintenance standpoint, how do they compare?
Similar, very similar. It really kind of comes down at the end of the day to the usage, just like anything else. The nice thing about the AGV is that you do have multiple devices running around. You could have one down for service, but you never would know because that AGV can be put in a unused parking space. Meanwhile, the rest of the AGVs are running around doing the operation. You know, when you're designing these systems, I always think of it like Noah's Ark. You want to have 2 of everything, right? So to have a system failure is pretty much non-existent. Now you could have a component that's down, right? But not the entire system. There's 2 loading bays, so All that's going to do is affect the throughput because everybody's now coming out of one loading bay or one lift versus two lifts. Pretty easy to work around. The majority of our problems can be dealt with remote access. Whether it's a sensor issue or something's reading something wrong, we can troubleshoot that remotely and bring the system back up online. One of the nice things about the AGV system too is it's interchangeable. Swap out my parking spot for a storage container. So this is a project in New York City where we have a mix of EV trays, regular trays, and we have storage pods. I can take a parking space now and turn it into a double-sided pod. So one parking space could be two pods. So off of that basement floor, there's a separate lobby where you would come and get your pod. In Valencia here, they wanted to maintain as much ground floor space for retail as they could. So we actually brought the trash chutes for the residential down into the basement, and the AGV manages the trash as well. So 4 trash bins on a tray, a recycle and a trash, and then it actually will rotate when they get full. So they put 2 more empty ones in there, and then it'll swap the 2 trays. So the trash guy pulls up to the loading bays, punches in his code in gray, and AGVs bring the trash to the trash guy. He pulls the bins out, and dumps them and puts it back in and stores it back.
It's sort of a complex decision process. What system are you using that's like most cost effective? How does this work in a design process?
Yeah, and usually they bring us on because they can't get the parking, right? The parking's either so inefficient that they can't make it work on these small urban infill lots. We typically will do a study and design to say, look, we can get this many cars using this system, we can get this many cars using this system, and here's your cost for each of those systems. So typically we'll do those exercises. We'll do a quick analysis, do a quick set of plans for the first go around. And then once you pick a direction, then we usually get a design contract to move forward.
You are installing this obviously towards the end of construction.
Yep.
How does that lead time play into the construction process?
We run a parallel process with the building. So especially in LA, if your parking is not code required, then you wouldn't have to parallel plan check. We will be parallel plan check our submittal package with the building submittal. So we are getting our building permit with the base building. And then once they start construction, we are going to start that fabrication process as well. So that once the garage is ready, all of the trades have done their work, we are going to come in and do our installation within that space. The plane slides probably the 10 to 15 hours per platform for installation purposes. For a double stacker, it's roughly 15 man hours per stacker. For a puzzle system, it's roughly 70 man hours per platform for installation. So for an automated, it's around 40 hours per parking space for installation.
Great. Well, that's the 4 categories that we set out covering at the beginning. Stepping back in terms of general questions on this parking system, have people used these parking systems for shorter term use? Say you're in pre-development on a site or there's a vacant site in a place that has little parking. Could you temporarily pop up a puzzle system?
Yeah, you absolutely could. We do that all the time in New York. So we work with a lot of the parking operators. The parking operators there, they don't own the land per se, so they will move systems from parking lot to parking lot over time. One we did in New York City, a leased puzzle system, 4 level, 11 cars wide, and then another section on the other side, 11 cars wide. So the whole thing shuffles as an entity. But that one is on there for on a vacant lot, 5-year period.
As you convert space away from parking in the future, is there a secondary market? If you wanted to disassemble that puzzle system, whether it's in the tuck under space or a separate pad where, you could build housing, I guess, in the future.
We actually have 400 plus spaces that we rotate through a rental fleet. Double stackers primarily, but we also do have some of these puzzle systems because the puzzle system is very much like a stacker where it's a modular system. You have the ability to also relocate that. That's one of the things we're trying to push is a standardization of that system so you can make it more modular.
In the future of parking, what's exciting out there?
So, for the future, what we're seeing municipalities is converting high volume spaces into other uses. It's a trend that we see all of our clients looking for, municipalities planning for. If you're building above grade, creating these higher volumes of space that then in the future get converted to other uses. So a car may not be a car. We might have flying drones. That system can be adapted and modified to accept whatever that vehicle of the future is. I look at this as a concrete structure, but it's a double height space. Well, in the future, I can come in and convert that to office or retail or commercial or other uses. That's where we see municipalities requiring the flat floors instead of slope ramping garages.
Yeah, that's interesting. And then I guess even if it does stay parking in the near future, it has to adapt to how cars are changing with EVs and sort of going more electric, right?
That's the other thing. So integrating better solutions for EV within them, so I don't have those cable management systems. I can do load balancing. I can shuffle the cars and have 10 chargers for 100 cars, so that demand on the building doesn't have to be the same. I charge them at different times, or the EV is built into the tray. And so as it slides back and forth, I can pull the cable out of that spool, plug in my car, and put the cable back in, and that's moving back and forth with the tray.
Well, yeah, I guess over time, I hope that cities will need less parking, but it sounds like the innovations and the future of parking is very electrifying, as we can devote less space for cars in our cities and more space for people. Well, Michael, thank you so much for your time.
Thanks, Charlie. Talk to you later. Bye.